Okay, so for this lesson, we're going to continue using an oscilloscope. We're going to continue using a function generator, but we're going to do something a little more interesting today. We're going to make it spin a motor. And we're going to talk about how you control the speed of a motor. So all of this is what the Arduino is doing for you under the hood when you tell it what to do with the code. But we're going to do it with this electrical test equipment kind of manually so you can see exactly what's happening. So I have one scope probe here that's connected to the output of the signal generator, and I'm going to clip it on here. And I have my other scope probe here, which is connected to channel 1 of my oscilloscope. I'm just going to clip them both onto the same spot. Now I have a ground clip that I'm going to connect to the return of the power supply, so everything's all grounded together and referenced to the same point. And that's all we need to do in terms of setup. Now we're going to go to the function generator. Okay, so here I have my function generator and an oscilloscope, and I have my circuit that I put up next to the scope so we can see the motor spin. And in fact, let me put something on the motor so we can see it spin a little easier. Okay. So now, first thing we're going to do is set up our square wave coming out of the function generator. So the type of wave that we use to control the speed of motors is called a PWM signal, or a pulse width modulated signal. It's a square wave, and we change the shape of it so we get more or less power into the motor. Now, why do we do this instead of changing the voltage? It's really processor intensive and electronics circuit intensive in terms of more parts needed and more complicated design. To have a circuit that can go from some voltage, 0 volts, to 5 volts at some smooth increment, it's a lot easier to turn something on and off. It's just a digital signal, right? A 0 or a 1. So what we can do is we can take advantage of the fact that motors react really slowly to electrical signals, and we can give it a pulse, a square wave, and the amount of time that power is on when the square wave is high corresponds to the amount of energy we're putting into the motor. And by changing the amount of time that the square wave is on versus off, we can control the speed of the motor. Again, this is because the motor is so slow that it doesn't react fast enough to see you switching it on and off. The inertia of the rotor keeps it spinning. What you notice is it's spinning slower or faster. But what we're doing is just turning it on and off really quickly. So without further ado, let's just set up the demo so you can see it in action. We're going to set up a square wave here. We'll go to waveform, square wave. And what I want is we're going to set the period first. We'll set it to 1 kilohertz, already there. Amplitude, we'll do 5 volts peak to peak, should be plenty for this motor. And offset is again at 2.5 volts, which means the 0 point is at the bottom of this square wave, and it goes up to 5 volts. It is not centered around 0 and goes down to negative 2.5 volts and up to positive 2.5 volts. We want it to go from 0 to 5, okay? And last but not least, we have something called duty cycle. So right now this thing is set pretty low, and in fact, let's see if it'll let me set it to 0. Okay, so now it's set to 0. So that's where I want you to start. So the other side of this, which you don't really need, but I'm connecting it for this demo so you can see what the waveform looks like, connected to the motor. This is what's going into the gate of the MOSFET. So this is the switch signal coming out of the function generator. This is what's telling the MOSFET to turn on and off, okay? So as you can see right now, motor is not spinning, and our duty cycle is set to 0%. Now, percent refers to the amount of time the square wave would be high versus low. So as I ramp